Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the fact that whether buoyancy follows the Newton's laws or not. So let us discuss a scenario in which there is a container whose mass is negligible and m mass of liquid is filled inside this container, and there is a block whose density is less than the density of the liquid and the mass of the block is small m. So this block is kept inside the liquid and hence it would float because its density is less than the density of liquid. So now we have to discuss that what will be the weight of the weighing machine. So if we consider this as a system, then the external force acting on this system will be m plus mg, and obviously the reading of the weighing machine should be m plus mg. But a question arises in the mind that why this mg is occurring in this reading, because this block is not in contact with the base. So let us discuss this fact. So in this case, if we draw the free body diagram of the block, then the block will be floating and hence the buoyancy will be balancing out mg. So buoyancy will be equal to mg. Now this buoyancy force is applied by liquid on the block, and if we draw the free body diagram of the liquid, then we will see that on the base there would be mg of the liquid plus the reaction of buoyancy, and the reaction of buoyancy will be equal to buoyancy itself, and it would be mg plus buoyancy. So it would be m plus mg. So the reading of the weighing machine would be m plus mg, as the buoyancy will apply, as the block will apply a reaction force that is equal to buoyancy on the liquid in the downward direction, and that reaction would be transferred to the base of the container. But what happens when the sigma is greater than rho? It means that when the density of solid block is greater than the density of liquid, then what will happen? So let us discuss this scenario also. So we will see that in this case the block will settle down to the bottom, and in this scenario, if we draw the free body diagram of the block, then we will see that the buoyancy and the normal reaction will be acting on the block in the upward direction, and they would be combinedly balancing the mg of the block. So n plus buoyancy will be equal to mg of the block, and if we draw the FBD of the container and the liquid, then we can say that the mg of the liquid would be acting in the downward direction, n would be acting in the downward direction, and the buoyancy reaction, which is equal to the buoyancy, would be acting in the downward direction. So the force on the base of the container would be equal to mg plus n plus buoyancy, and n plus buoyancy in this case is equal to mg. So it would be mg plus this is small mg. So the reading will be m plus mg. So still the reading would be same, and this you can also conclude by the fact that when you are considering them as a system, then the external force acting on this system would be m plus mg only. So there would be no question of the change of reading of weighing machine. So guys, this was it in this video, and in the next video we'll be discussing some more amazing concepts of buoyancy. Thank you.